Hello children, how are you all? Today we are going to enter into a new year of our class 9. So I'm your physics teacher, Lakshminarayan, and I'm here to help you understand something of your daily life. So I want to ask you one thing before I enter into the details of the first chapter of our lesson. What I want you to do is answer my simple questions. What do you see all around? You see certain things, yes. So what are the things that you see around? So you'll see the tables, the chairs, the next to the sand outside, the particles of the sand, and there's invisible things where you feel them like air through the breeze or wind. That's correct. And the next, a few more things like the water that's flowing, then a food that we eat. All these are called as material. What are they called, children? They are called as material. And this material was called by scientists as matter. Now, you know matter. So, in the earlier classes when you were very small, you have already learned what matter is. Now, the scientists gave an idea what matter is. Anything which has mass means that which is tangible and you can feel it by holding or feel it by something which touches you. That is called as mass. And volume. What is volume, children? We learned that the amount of space that a matter occupies, that is called as matter. So matter has two characteristics according to the scientists. What is that? Mass and volume. Anything which has mass and volume, that is called as matter. Now, can I call heat, light as matter? No, we cannot call them as light and heat as matter because they can be felt, but they cannot be touched and felt. So that is not matter. So now that is matter all around us. That's correct. So we are going to talk about today the matter in our surroundings. Matter in our surroundings. That's the thing that we are going to learn today. Now we talk about the thought about this matter. Thoughts about matter. Right. So what are the different thoughts about matter? So ancient thought, and modern thought about matter. Modern thought about matter. Right. So what is this ancient thought? So the philosophers, the Indian philosophers, and the Greek philosophers, philosophers, philosophers. Right. They thought that matter is made up of according to these, matter is made up of five elements. Five elements. Elements. What are these five elements? They are called as the Pancha Tattva. And these Pancha Tattva are air, water, fire, sky, and what else? Have you heard about Panchtattva? Air, water, fire. The next one. Then the last one is soil. So this was the old thought or the ancient thought about matter. Now, at present, the Greek philosophers also thought just the same way like our Indian philosophers. Now, what is the modern thought about matter? Let us see. Modern thought has defined or explained matter on the basis of what are called as two things. One, the physical properties and chemical properties, physical and chemical properties. So it was not so neat, so I erased again and started the recording again back. Right. So ancient thought was Indian philosophers and Greek philosophers. They thought that the matter was made up of panchatattva, the five elements, and modern thought is based on, or matter is explained based on physical properties of matter and chemical properties of matter. Now, next, children, we'll try to. So we'll not be talking about chemical properties now, but I will try to explain matter on the basis of physical properties. So the physical nature of matter. Now here we're going to talk about the physical nature of matter. What is physical nature of matter? Physical nature of matter. Now, there were two thoughts about the physical nature of matter. That is the thought of continuous nature, and the particle nature of matter. So we'll check whether matter is continuous or particulate. So what is the meaning of this? So imagine I have taken a duster, and this duster is one piece. So the thought of this group of people was that if a duster is this, it's all one part, and there is nothing more in it. So it's all one. So whenever it is broken, it is not, in one way, it cannot be broken into smaller things, but that's not happening. But still, we see that this is continuous. I mean, if at all this duster moves, it moves the whole. Right, next, and the next is the particle nature of matter. Particle nature of matter tells that if this duster has particle nature, then this duster will be having particles. Now, who is correct? Whether the continuous, this thought, the people who thought continuous nature is right, are right, or the people who said particle nature is correct. So this can be understood by a small activity that we are going to perform. Now I'll try to explain to you the nature, but later on I'll get into the details, and you will understand it better when we do this activity in the class. Now, okay, right. So we'll try to understand what the nature of matter is, or what is the characteristic nature of the matter. So what I do is, now we'll try to understand the activity one. Now, in this activity, we are going to take a beaker of 100 ml, and pour some, say, 50 ml of water, 50 ml of water in it. And the next, take some sugar, a spoon of sugar, put into it, and stir it, stir it. So when I stir it, all that sugar, it dissolves. Now, if I keep an iron nail or some heavy object into this, I find that the level would rise. But when I put this sugar into the water and dissolve it, I find that there is no change in the level. That means when I added sugar, before adding sugar, I note the level, and when I add the sugar and dissolve it, I still find the level of water has not changed. Now, what might be the reason? The reason might be this, that there may be some spaces between the particles of water, or I can say that I can say that the matter of water, there might be some spaces. Okay, right. So the small amount of sugar that I have taken, that might have gone into this water. So where did it go? So if it is one continuous material, how can it go? It can't go, is it not? So that means from this we understand that the small sugar crystals, they may be having many more small particles which got divided due to some forces acting in water, and they are all spreading and going into some spaces somewhere in the water. So when those spaces were occupied, the water level did not change. It's just like I'll tell you, children, if there's a packed room, imagine there's a very tightly packed room, and you are trying to come in. Can you come in? It's not possible for you to come in because there's not enough space for you to come in. But if there are a few seats available in this room, or a few places available, so when you come in, what can you do? Can you come? Yes, you can come and also occupy some place at some corner or the place where it is vacant. Is it not? Just like that, matter of water is not continuous. It is having some kind of spaces in between, and these sugar particles also, they are not continuous. They are broken into smaller, very smaller parts, and have gone and occupied the places that are there in the spaces of water particles. So that's, children, we understand that matter is not continuous. Matter is particulate. It is particulate. It's made up of particles. So this is the first activity that we have done, children. Now, children, we move to the second characteristic of matter, or nature of the matter. So what is that? So here, to understand that second nature, which I'm going to tell you, that I take, say I have to take say 10 beakers, but here I'm showing you 10 100 ml beakers, And in the first one, I poured 100 ml water, and the next one, I poured 90, 90, 90. Right, and next. In this, I have to put, say, if I put, say, potassium permanganate, it will turn a pink color. And the next one, if I use it, I can use any coloring substance like copper carbonate, copper sulfate, or anything. Right, I put, say, copper carbonate. So the activity, I'll show you copper carbonate there. So I take blue crystals of copper carbonate, say a small crystal of copper carbonate, when I put it in there and leave it, what happens, children? So it will all turn blue in a very short while. Right, the next one in a very small time. And now I will take 10 ml using a syringe or otherwise any test tube, and transfer that 10 ml into this. So now the solution becomes 100 ml. But one thing is different. There is some difference between these two. So this is not as thick or dark in color as this one. Right. Now, then next I transfer 10 ml of this into this. I find that this is further duller in color than this one. And again, I do the same. As I continue, I find that this is dark blue, this is lighter, lighter, and very lighter, and the tinge is still there. I find that in all of them, I find there is that small tinge of blue. If I take copper carbonate and if I take potassium permanganate here, I'll get the pink color. So I understand there's something here. So a small crystal of copper sulfate or nearly a very small crystal of copper carbonate or a small crystal of potassium permanganate, it is now able to color almost 1000 ml of water. Now, what is the reason for it? So now, if it had been continuous, it would not have done so. Right, it is not continuous. So it is having particles. That's true. How small are these particles? A small crystal, when they are taken, that small crystal could uh, it could it could colorize nearly 1000 ml of it. So what you can understand from it, children? There are so many particles in that small crystal, and it is given that a small crystal of sugar or copper sulfate like that that is having nearly 10 power 18 particles closely packed, densely packed within that small space. So that dense is the material of the matter. So we understand that matter is particulate. That's correct. And second thing is matter is made up of very very tiny particles, densely packed. So that's where we conclude our chapter. So first part here. And before that, we just recapitulate. As children, we return back to our lesson, matter in our surroundings, the first part, module 1. And here, we just recapitulate about what we have learned just now. The first thing, right, the recap, all the things that we are able to see, the material, they are called, the surroundings, they are called material. And that material, by scientists, they are called, that is called as matter. It has mass and volume, that's okay. And the next one, what were the thoughts about matter in the past? People thought that matter was in ancient and modern thoughts, and ancient thought states that there's made up of pancha tattva, and modern thought explained matter with the relation to in relation to physical properties and chemical properties. Then nature of matter. Matter is made up of particles or matter's particles, and the particles of matter are very very small. Now, following this, children, there'll be a worksheet given to you, and you go through your textbook, the same part from your textbook, go through the lesson that we have seen in the demo, and do well, children. Read it, concentrate on that, try to think, and fill your worksheets and bring them. Fill your worksheets and bring them when you are returning to the school. All the best to you. I'll meet you the next time. Thank you.
Children, let us do the activity 1 that we have learned in the lesson during the class. I've taken a glass of water and note down the level of water now, and we will now add some sugar to the water, and let us stir the sugar and see. And we are stirring the sugar to dissolve it, and also observe the level of water after the sugar has dissolved. So there we are, almost done. And you find that the sugar has dissolved now, and check the level of water now, and you won't find any increase in the level of water or change in the level of water. Alright, so we understand from this that the particles of the sugar have dissipated, and all around the particles of water, particles of sugar has dissipated into particles of water, into between the spaces of the particles of water. So we understand that matter is not continuous, but it's made up of particles. So children, let us do the second activity. As you can see, there are 4 glasses, and in all of them there is water. But in the first glass, there is 10 ml of water more than the second, third, and fourth glasses. Now we're going to add copper carbonate crystals. Copper carbonate crystals, they are blue in color. I'm adding copper carbonate crystals to the first glass, and I mix. So I find that the solution, it becomes blue. So the quantity of the solution is approximately, say, 100 ml. And now, but in others there are 90 ml of water. Right. Now we're going to transfer this 10 ml of this solution from the first glass and put into the second glass. So this is a 5 ml syringe, so I'm using that twice. So okay, right now, so you can see now the solution is 100 ml of solution there. So we have seen a difference between these 2 glasses. As the first glass is very dark in color, but there is color. The blue color is still there in the second glass, but it's a little duller. Now what I do now is take 10 ml of this and add to the next. 10 ml I'm taking, adding. Do you see the color is it has acquired some tinge of blue, but it's not as blue as the first or the second one. Now when I transfer 10 ml of this into the next one, I find I get the 100 ml of solution, but the blue is very dull. The dullness is very much visible. So what we see is there is the color blue in all of them. So it implies that the copper carbonate molecules are there in all of them. So a very small crystal of copper carbonate, which has made this blue, has so many particles, and out of them I have transferred some here. What is it? They have spread there, and then again here. So it implies that. So it implies, so though the through all of them you find some blue color. So the particles which have become free, when they are added here, they are still there here, and they are there here and here. In all 4 glasses the particles are there. So it implies there are particles in the matter, and the particles are so tiny that even a small crystal of a copper carbonate that we have used here, that could dissipate so many molecules, that is making all of them to have that blue tinge of blue color. So that's, children, so we understand that from this activity that the particles of the matter are very tiny. A small crystal of copper carbonate, it is having a large number of particles in it, right?